Hello everyone. In October of last year, I heard that a comet would be visible in our area. And so one day, my wife and I, we went to the Skyline Boulevard. It was foggy and we couldn't see anything, so I came back. And then a day later, we again went up and somebody said that if we go further south, we might be able to see. So we drove further south and I saw a bunch of cars parked in the area. And so we parked our car there and saw some people looking at with their iPhones and other things. But there was one space, few people were gathered around. And so we went there, and then there was, this man was explaining to people, where to find the comet, what to look at, and he had his device there, and we went and looked, and we saw the comet ourselves, but until that time we couldn't see anything. And then he explained a lot of things that I found were very interesting. And after seeing the comet and before leaving, I just said, I belong to this fellowship forum. Would you be able to come and give us information about what you do and how you know all of these things? And he was very willing to come. So that's how I met today's speaker, Ron Sheldon, and I asked him if he could formally come here, and he was very open to come, and so that's why he's here today. Ron has always been curious, and he knew the planets, major constellations, and the names of brightest stars when he was only 5 years old. He even remembers seeing comet Ikeya Seki in the pre-dawn sky when he was only 4. He got his first small telescope when he was 14, and then got a larger one with an 8-inch diameter mirror 3 years later. And I'm telling you these dimensions. I'm not that familiar with all this, but it must be pretty big. He currently has a large portable telescope with a 15-inch mirror that he uses for astronomy and for recording rocket launches from Vandenberg Space Force Base in Santa Barbara County. And he'll probably show us the picture of his telescope. Is as tall as I am. He was a product development consultant for about 20 years and has 6 patents, 4 for medical devices and methods and 2 for communication device. He designed equipment for medical device and telecom companies along with a startup and a non-profit organization. He left consulting behind in 2005 when he became the stay-at-home parent for his 2 children. And that was the most rewarding career choice he ever made. He is here today at my invitation to share his passion for learning and understanding some of the wonderful and amazing things that are out there beyond our little planetary home. So here is Ron.
Hello, good afternoon. Thank you, Satish. It was an exciting event last fall when the comet came, and its name is Comet C 2023 A3 Tsuchinshan Atlas. Most people prefer to call it Comet A3, so that's what we'll refer to it as. I'll show you the first pictures we took. So this was the night before. This was the night that Satish was unable to see. I found a spot up on the skyline. This was the first day that the comet was going to be visible. I hadn't seen it before. The last time I had seen a comet was, I had seen one a couple of years ago, but Comet Hale-Bopp from 27 years ago. It's very, very well known, very well easy to see. I wasn't sure what we'd get. And as the sun set and the sky got darker, it's like there's still no comet. Where is it? Well, finally, at about 7:15, I don't know if you can see it, but right there. Okay, let's go to the next one. Okay, it probably would help to have the lights a little bit dimmer. I don't know if we can do that. But this is also what was sort of happening. The moon was almost full, and so the sky wasn't dark. It's very close to the western sun's horizon, so it was not terribly bright to see. It was actually very bright in the sky. It's very, people are calling it the Great Comet of 2024 because it was magnificent, but just the viewing wasn't perfect. If it happened a week before or a week later, the moon would not have interfered, and it would have been just this dazzling object hanging in the western sky. Everyone would have seen it. On the next night, this was the last picture I took. It zoomed in. This was just with my Google Pixel phone. It was nothing special, but it has something called night sight, and it lets you take a longer exposure picture and sort of keeps it stabilized. The next night, this viewing area was definitely fogged in, and I went up to farther, almost to the entrance to El Corte de Madera, if you know where that is on the skyline. And that's where, oh, thank you. This is where I met Satish and his family. And here we are waiting. And one thing that is helpful is I have this great astronomy planetarium program. It's called Stellarium. It's absolutely free, and it has all the information you could ever imagine. And you can plug in the date and time where you want to look at something. And so they told me on that night that this white star here is Arcturus. This is Arcturus. This down here is Venus. It's not as bright as Venus is right now because it's farther away from the sun back then. But I knew that the comet was going to be right about in there. And sure enough, once it got dark, there it was, exactly in between the two of them. And this is a picture, so Satish has a photo similar to this because we were looking. And this night I brought binoculars with a tripod. And I was able to take, I didn't bring my big telescope, because it's not great for looking at comets. Comets don't have any detail, they're just big, fuzzy, and kind of bright. But the picture I took through, well, this is still with the pixel just by itself, as the comet was getting lower. But this is what I took through the binoculars. And it looks a little bit blurry. The trees are blurry because they're too close, they're out of focus. And there's this interesting sort of, these little pinkish clouds. Those aren't real. The Google Pixel has an infrared light that it uses to focus, and that was reflecting off the lenses of the binoculars and being picked up by the camera sensor. So it looks beautiful, but it's fake. It's not real. And I tried to Photoshop it out, but it just kept ruining the comet. So I said, forget it. We'll just leave that in.
Good job.
Yeah. And once you knew where it was, I could amaze my friends. I could go over and say, there's a comet above your house. I'm like, what are you talking about? And this is my house, and there's a lot of street lights. You can see how bright it is. But you could see, if you knew where to look, this smudge. And if you took out your camera and used the night sight and took a longer, this is like a 3-second exposure. Instead of just this little dim smudge, you see a tail. And this tail was real, and this was the 16th, so this is the third night that I saw it. After this was about the best viewing we had because the comet came between the sun and the earth, and now it's moving away from both, so it's getting farther away, it's getting smaller in the sky, it's getting farther from the sun, so the gas and sublimation that's happening on the nucleus is fading, it's starting to wane. I'll come back to the comet in a little bit. But I thought for this show I wanted to sort of share this, but also talk more about like just what's in the sky and how big this is. How do we fit into this? So in December, I noticed that there was it's called a conjunction. You have two celestial bodies that are near each other, obviously in the sky, not necessarily next to each other in real space. But here's the moon and Venus. And this was taken before sunset. This is during the day. Because you can see Venus during the day. It's bright enough to be seen in broad daylight, as long as you know where to look. If you have binoculars, it's very easy to see, but even with your naked eye. And on this evening, there was this helpful, crescent moon that was right next to it. And so here we are looking at this, and it's interesting to see what's beyond this. So again, you're looking out, and here we are at in the evening, and we're looking at two objects, yes, they're in the sky, they're far away, but how far away are they? This is from the planetarium program. So if you can see, the phase of the moon is exactly the same, the orientation is exactly the same, and so the moon is probably 20% illuminated. And you look over here, and this is Venus at the same magnification. So right away, this tells you that Venus is a lot farther away than the moon. Well, let's make it easier. Because it's the planetarium program, I can do nice things like zoom in. So this is what Venus looks like if we could magnify it quite a bit more. And you can see I've added the distances. So the moon is not even 250,000 miles away, yet Venus is 88 million miles away. And you also notice something interesting, that the moon is a crescent. They're next to each other in the sky. Why isn't Venus a crescent? Doesn't make sense. How can they be next to each other and they're not the same phase of illumination? Well, it's because of geometry. The moon forms a triangle between the sun in front of us. I'm the Earth, here's the sun. The moon is over here, and it's mostly in front of me. It's much closer, not close to the sun, but it's on the sunward side. And so only a portion of the sunlit side is visible. Meanwhile, Venus, at 88 million miles away, is almost as far away as the sun. But it's coming around from the backside and out. So it's in a place where it's a little bit more than half illuminated. Probably wouldn't have known that, but that's how it is. Another event that happened recently was on the 16th of January. There was this was not even more than a conjunction, this was called an occultation. An occultation is like an eclipse, but usually where one body is way bigger than another. And this is where, that's Mars at the top, right here. And this was taken about 4 hours after the occultation. For us in California, the event happened with the moon and Mars below the horizon, before it had risen, so we couldn't see it. But if you were in the North Atlantic at the right amount of time, like I can take us with our planetarium program, you would have seen this if you had a telescope. The moon, this is Mars. There's no like focus distance. Oh, like the moon is right in front of me, so I have to focus on that, I have to focus on Mars. Everything is at infinity as far as photography is concerned. So you're just looking at the moon, which happens to be 250,000 miles away, versus Mars, which is almost 60 million miles away. And so in the planetarium program, you can play. You can sit, watch the moon go right over Mars, and watch Mars pop out the other side. It's all kinds of fun you can have with that. And the last thing I want to share about sort of things that happened recently in the night sky. And again, this doesn't require any tools. These are just things you can see. On the 16th of January, there was this nice triangle in the western sky. So this is just a random star, and obviously Saturn and Venus. And the thing to notice here is there's this reasonably nice right triangle. And yet 1 day later, that triangle is gone. It's a totally different triangle. And you'll notice most of it is because Venus has moved from here to here. But also, if you notice carefully, Saturn has moved from kind of here. Well, Saturn was here last night. It's moved this direction. And the numbers here tell you a story. If, oh, can't stand there. So on this night, Venus was 58.69 million miles away. The next night, it's 58 million. So during the course of 24 hours, Venus has caught up with us by 690,000 miles. The Earth is not standing still. Earth is moving around the sun. But Venus moves faster. So even though the Earth is moving, Venus still caught up with us and gained almost 750,000 miles. Meanwhile, Saturn is at 952 million miles. It's on the far side of the sun. It's also moving, but it's very slow, and it has a very long way to go. So we are pulling away from Saturn very quickly. So again, in 24 hours, we went from 952.4 to 953.6. We pulled 1.2 million miles farther away from Saturn than we did in 1 day. Then we did the big four. So this, and Venus is catching up on us. So this is some of the dynamics that are happening. You just look up, oh, there's Venus, and there's a couple of stars, but this is, in one day, you can see motion like this. Oh, and this is through the planetarium program. This is what it looked like. And you'll notice that Venus is now half full. It's what we call quadrature.
Hi there, video editor Ron here. I got that totally wrong. Quadrature is something that only applies to planets with orbits outside of Earth, so Mars, Jupiter, Saturn, etc. For inferior planets, Mercury and Venus, the 50% elimination happens at something called the maximum elongation. That's when the planet reaches the farthest point in the sky away from the sun that it will reach during its orbit. And this photo was taken right around the time of the maximum eastern elongation of Venus. So that's why it's 50% illuminated.
Leaves it half illuminated, whereas before it was more than half illuminated. Meanwhile, Saturn is fully illuminated because it's an outer planet, and all the outer planets are they're always behind us. The sun is always behind us, or it's behind the sun. Either way we look, they're always fully illuminated. You can never see a crescent Mars or a crescent Saturn. It's not possible, not from Earth at least. Voyager and Cassini have taken those pictures. Okay, so I'm telling you all this because one of the things that's hard to really convey is a sense of scale. And you can talk about numbers and say something's X number of miles away, or light takes this long to go somewhere, but that doesn't mean it's easy to understand. I'll give you an example. For some reason, my daughter got me a Starship Enterprise model for Christmas, and I looked and I thought, oh, thank you. And on the box it said it's 1/1000th scale. Okay, so I have in my head how big that is. I mean, I know in general how big the Enterprise is supposed to be. And so 1/1000, well, I'm expecting it's probably going to be, about this size. This is about the size of Mars, right? Well, this is 1/1000th the size of the USS Enterprise. It seems small. And, I measured it, and it's 1 foot long. And the actual Enterprise is allegedly, or would be, 1,000 feet long. So here you can see, okay, here's an aircraft carrier and a starship, that's the constellation, but the same idea. And, okay, so that makes sense. But would you guess that 1,000th of that size is this? I wouldn't. This seems too small. And then it's even harder if you want to represent things on widely different scales, especially in the same medium. So here's an example. If you wanted to look up solar system objects, this chart has a lot of information in it, and most of it's garbage. It's more confusing than it is helpful. The only thing, literally, this is sort of helpful because it shows that the inner solar system, the terrestrial planets are very closely packed, and then you get farther and farther out and the big planets get out there. But it's hard to really make sense of that. This is the best part, where they show the planets to scale. Because Mercury is smaller than Mars, Venus and Earth are almost twins, Jupiter is 11 times the diameter of Earth, and 111 Earths can fit inside Jupiter. Jupiter is massive. Saturn it's 86,000 miles across, Saturn is 77,000 miles across, but its rings are 170,000 miles. So you look at this, this is very useful to see how big these other planets are relative to Earth. The problem with this and most of these kind of graphics is then you have this stuff. And what on earth are they even doing? This says the sun is twice the size of Earth, and Earth is only slightly smaller than Jupiter. This doesn't make any sense. This is confusing. There's all this other nonsense about stars that have nothing to do with anything. So this is just more confusing than helpful. This one is not quite as pretty, but it does a better job, because here, not only does it show the planets to scale, it also shows the sun to scale. The sun is 864,000 miles across. The sun contains 99.8% of the mass of the solar system. Jupiter contains 99% of the rest of the mass. Saturn, Uranus, Neptune, Earth, all the asteroids, everything else in the solar system is 0.1% of everything in the solar system. So the sun is gigantic. This also has a little bit of a scale from the galaxy to the Oort cloud and the solar system in the center, and then the solar system here. But again, here we have Jupiter way bigger than the sun. None of this stuff makes any sense. The other good thing this does is it does try to show down here in this little axis, it does try to show you a sense of scale for how far away these are. And astronomers like to measure distances within the solar system in something called astronomical units. And so that's the distance between the Earth and the Sun, which is on average 93 million miles. So here we are on the Sun, and this is from the center of the Sun. So the Earth is 1 astronomical unit. Mercury is about 0.3, Venus is about 0.6, Mars is a little less than 2. And you can see that here, they're all sort of evenly spaced. And then you get out, so it's 2, 3, 4, 5. Here's Jupiter. So Jupiter is at 5 astronomical units away. It's farther out. You have to go to 9.5 or almost 10 to get to Saturn. Then you have to go way out to 19 to get to Uranus, and then out to 30 to get to Neptune. So this does give you that information, but it's not easy to digest. And about the only way you can really show distances like that in a way that is scientifically valid, but it's not terribly intuitive, is to use a logarithmic scale. So here again we have the 1 astronomical unit, and this is 0.3, 0.6. So here's 2, and Jupiter's at 5, and on a logarithmic scale, that's exactly where you expect it. Then 10, 19, 30. And now you get out here to 100 astronomical units. So now you're at 9.3 billion miles. And that's way past the orbit of Neptune. And it's where you start to encounter interstellar space. You start to lose the influence of the sun. And you get out to 1,000, so 93 billion miles away. And now you start to get to the edge of what's called the Oort cloud. Nobody has ever seen the Oort cloud because it's so far away and it's so faint, and the bodies that must be there are tiny. You can't see them with Hubble, you can't see them with Webb, you can't see them with any telescope. But here at 93 billion miles is about where it starts.
And then it continues. It's a sphere. It continues on for another 100,000 AU. That is 9.3 trillion miles.
So, but what do you do with this information? You can't comprehend it. By the way, the comet A3 has come from here, and it's taken 40,000 years to get into the solar system. So one way around these limitations, is to do what I'm going to attempt to do here today with 2 volunteers. Satish and Bruce, could you come? And I understand I'm not from Palo Alto, but I understand in Rinconada Park there is the scale solar system with markers. As you walk across the park, they take you to each of the planets and with a plaque, and you walk until you reach each planet and you are aware of how long these distances are. And so the model I'm going to share today is at a scale of 1 to 100 billion. So 1 times 10 to the 11th. Does anyone have any idea, if I shrink the sun by 100 billion times, any idea how big it's going to be? Well, it's this size. So half an inch, just over half an inch. And Satish, I'm going to ask you to just gently unroll that. And here, you take, just start with the smallest. Okay, so stop. So here's the sun, and at this scale, we need to scale everything. So right here where this first dot is exactly, that is Mercury at this distance. And the dots here, by the way, I don't know if you can even see the dots. The dots are the size of Jupiter. Each dot here is the size of Jupiter. So
How many times bigger than the Earth?
it's 11 times bigger than the Earth. So these dots are not representative. They're just something I can use to show where the planets are. And we'll have to use our imagination. So here we are at Mercury, and now we've gone to Venus, and Earth, which takes 1 year to go around the sun, is out here at 93 million miles away. So again, and let me give you a scale here. If you were to draw Mercury to scale, if you took the sharpest pencil you had, and you made the tiniest dot on a piece of paper you could make, that's how big Mercury is. If you look at Earth and Venus, and you have a 0.5 millimeter mechanical pencil, if you could shave that down so it's 1/4 that diameter, that's Earth. Okay? Well, we lost Venus, that's okay. So we go out further, because Mars is 2 astronomical units, so it's twice as far away as Earth, if I did my model correctly.
Oh, did we miss the one there? Between here.
No, this one fell off. But are you at Mars? So Venus fell off. That's Earth there. Okay, and so keep going. So this is Mercury, Venus, Earth, and Mars. These are the terrestrial planets. And if we're talking light speed, light takes 3 minutes, moving at 186,282 miles per hour, 11 million miles per minute. It takes 3.2 minutes to reach Mercury. It takes 6 minutes to reach Venus, 8.4 minutes to reach Earth. So the light, when you look at the sun, you're seeing the sun as it was 8 minutes ago. It's not now, it's already old. So you get out to Mars, and we've got a nice pink little Mars, but where's Jupiter? I thought on these maps, it's like Jupiter's right next to Mars, isn't it? No. Still on Jupiter? Where? Oh, did I make a mistake? No, I didn't. Keep going. It's 25.6 feet away. And by the way, I stayed up till 12:30 last night making this model. I'd never seen it in real life. This is my first time doing this. Still up to Jupiter, by the way.
You have to go to the other room? Oh, here.
Yeah. Oh, we finally arrived to Jupiter. Okay, and there's no way we can even get to Saturn, because Saturn is twice as far as Jupiter. Uranus is twice as far as that, and then it's 148 feet to Neptune. If we're doing
the
this.
Stanford Museum?
Yeah, so from here, I was hoping I could at least get to Uranus. I have 100 feet here that I was going to get to, but it's too small. But there's a couple things I want to say here. At Jupiter, this far away, any of you who are engineers or physicists know that light and radiation follows an inverse square law. So here we are at Earth. We get 2 watts per square meter of power. Once you get out to Jupiter, you have 1/27th the light from the sun. So 3.3% is all the light that Jupiter gets. And if you've seen the Juno mission, it has gigantic solar arrays. They're like 20 meters long on each one, because it only has 4% the light of this to work with. If you get out to Neptune, it has 1/906th the light of the sun. So the sun is only getting 1/10% of the power, the solar power. But what does that mean? Again, we're into meaningless numbers, because is 1/10% of the sun, is that dark? Is it like just at sunrise? Well, a tenth of the power of the sun is still 630 times brighter than the full moon. So somewhere between, it's probably about dawn. Probably around dawn is what life is like on Neptune. And I want to tell you two more things here. At this scale, remember we have Neptune at 148 feet. Remember I talked about the Oort cloud. This is where the comet came from. At this scale, the beginning of the Oort cloud is between 2 and 5 miles from here. There's nothing between here and there. It's still part of it's an interstellar space, but it's still gravitationally bound to the sun. And the far edge, now you're talking San Mateo and Cupertino. That's what, at this scale, you have to go all that way to get out of the Oort cloud.
I'd like to add that the outer edge of the Oort cloud may not stop at 10,000 astronomical units. Instead, it may go out to 100,000. Which means it extends out to 9.3 trillion miles, which at this scale would extend from about Cloverdale in Mendocino County all the way down to Big Sur in Monterey County.
And you might be asking, well, what about the nearest star? Like, where is that? How close is that? At this scale, if you go to Alpha Centauri, it's 4.2 light years away, about 24 trillion miles. Again, that's meaningless. But at this scale, if you wanted to visit the nearest star, imagine there's nothing between here and the destinations I'm going to give you, nothing at all. But you would have to somehow get your way to Eureka or to Santa Barbara. That's the closest star. We are not going to the stars, not in any conceivable part of my lifetime. And just one other thing to tell you, we launched Voyager in 1977. It took 2 years to get to Jupiter. That's pretty impressive, to get this far in 2 years. It's been traveling for 40 years now. More than 40 years. It is, if I would have placed it on this map, it flew under the south pole of Saturn and it's gone now up above the polar, above the plane of the solar system. And right now, it is 817 feet away from Earth, from Mars, from the sun. So imagine, across El Camino, onto the Stanford campus, and it's also 300 and something feet above us. I had I wanted to put in some pictures of Voyager and the thing, but my talk was already too long, so I had to get rid of those. Oh, and thank you guys, let's bring it back.
Come back to Earth.
Come back to Earth. Yeah, and I had meant to sort of be skipping through this over the Sun, Mercury, Venus, Earth. These are all just the nice glamour shots of the planets. So the last one we could get to here was Jupiter, again, 11 times the size of the Earth. And then we get to Saturn and Uranus and Neptune. And just to come back to the comet to close out, again, it's Comet A3, and it came from the Oort cloud. This is, again, it's symbolic of it. And so the planet of the solar system, this is the orbit of Neptune. And this is the Kuiper belt. There are other objects like Halley's Comet come from the Kuiper belt. But this is vastly larger. And the comet that we saw came from up here somewhere. It came way above the solar system and then dropped down. And if you look at this animation, this is just of the inner solar system. And you can see how these are the 4 terrestrial planets. And this starts on January 1st of last year. And this is a view from above. It's above the north pole of the sun, and the planets are going around. And these little lines here show that the comet is above the plane of the solar system and it's coming down. And it's actually coming in a retrograde movement. It's coming against the flow of the planets. This day, right here, the 15th of October, was the day I met Satish. And you can see that the comet had just come past its closest point of the sun, and here's Earth, And it's in this nice, very close angle, so it's very close to the sun in the sky, it's very bright, it's very close. And then it continued on, and if we just let the animation play forward, so here we are up to about, we're already past it, we're up on today right now, so that's how far it's gone. But the comet is totally faded from view, you can't see anything. Even the biggest telescopes can barely see it. And it's off into obscurity. And nobody knows if it's on an 80,000 year orbit, and it may come back. It may be on a hyperbolic orbit. It may be, this was the only visit it ever had ever. So it came in and it gave us a nice show. And one thing I do want to say is, I know we've sort of taken the solar system down, but remember how the sun is just this little thing, and the planets are stretched out here, and they're never, ever, ever in a straight line, by the way. This is just for show. They're always somewhere else. But for a few weeks in the past year, something was different, and this comet, oh, I have this. This is from the European Space Agency's Rosetta mission. This is a different comet. It's Churyumov-Gerasimenko. And these are always named after the astronomers from the observatory who first discovered them, so they get their names memorialized. So this was a probe that flew out to the comet and actually had a little lander called Philae, and it landed on the comet. But this is what a comet looks like up close. This is about 1 mile in diameter. 1 mile in diameter. And you can see there's been a lot of erosion. This is a comet that sort of stays at about the same distance from the sun. It's not too far from Earth as their orbits go around. But this is what's happening. You can see the gas and dust lifting off of the surface. And that's what forms the coma, the head, and then the long tail. And so remember that this is an object that's 1 mile across. And yet for a few weeks, just this past year, we were blessed with this wonderful object. Now, obviously, this is not my photo. This was taken from Arizona. And this was on the night of probably the best viewing. And you can see that at the time, it was 56 million miles from the sun. So not quite halfway between the sun and us. It was 46 million miles from the Earth. The coma diameter, 400,000 miles. Well, how big is the sun? 864,000 miles. That means that this little 1 mile rock has emitted a cloud of gas that is half the size of the sun. And this tail, it went on for 12 million miles. And the thing is that the tail always points away from the sun. It's not like a meteor that it leaves a trail behind it. As the sun, I'll do it this way. If this is the head of the comet and this is the tail, and if the projector is the sun, the tail does this. So when we saw it, the tail is preceding it away from the sun. That's what this is. The tail is leading it. And if you remember the solar system that we had here with everybody strung out on that exact same scale for a couple weeks, this is how big the comet was.